Hi Year 12s, I'm going to go over question 3 from the January assessment. This is a really standard question, and so it's really worth making sure you're really confident, it's a lot of reallys, with differentiation from first principles. If you're ever asked to differentiate in a question, it's just use the rule, except if it makes it really clear that it wants you to do it from first principles. The other phrasing might be prove that the derivative of x squared minus 4x is equal to 2x minus 4. Okay, but it's a standard thing they're going to expect you to do at some point in one of the papers. Luckily, you get given the formula for it. Okay, so that helps, doesn't it? Right, so given we've got f of x is x squared minus 4x, we've got to show that f dashed x is 2x minus 4, so we're going to start from here and just pop it in there. Okay, so we've got f dashed x is equal to, I'm going to quote the formula, and then I'm going to substitute in. I like putting curly brackets to show what I'm making the limit of, but you don't have to. Okay, now you cannot miss out some of the writing. Okay, you have to do it. This is a real thorough justification. So the limit as h tends to 0, notice I'm not putting equals, I'm now putting my brackets. Okay, so now I'm going to replace this. So we've got f of x up here, haven't we? Okay, so if we want f of, and the input being x plus h, that means wherever we see an x, we've got to put an x plus h. And because it's got two terms, I would put them in brackets. So we've got x plus h squared. Okay, it's not x squared plus h squared, it's x plus h squared, because it's the input squared. Minus 4 lots of, instead of x, x plus h. Okay, so we've just dealt with f of x plus h there. That's all we've put. So now we need to take away, and it's this function. Now this function has two terms, and so I'm going to put that in brackets, especially because there's a subtraction there, so I don't want to mess up my signs. So take away x squared minus 4x, which is the f of x. Alright, over h. So just trying to make that super duper clear. So here our input is x plus h. Okay, so in this expression our input is x, so we have to replace every x with x plus h in brackets because it's more than one term. Okay, right, and then what we've done is we've taken our f of x plus h, that's that bit here, and then we've subtracted the whole of f of x. Okay, and we put it in brackets because f of x has more than one term and we don't want to mess up our signs. Okay, that seemed to be where the most mistakes have been made, so that's why I've gone over it really carefully. Right, so now it's just algebra, but we have to be careful not to make mistakes. So we're going to expand out those brackets. Now if you're not totally confident you should get 3 terms from this, I would write out the brackets like we recommended at GCSE, side by side. So x plus h squared is this. So when you expand those brackets out, you're going to get x squared plus hx plus hx plus h squared. Okay, so altogether that gives us x squared plus 2hx plus h squared. Okay. Next bit, negative 4 times x, so minus 4x. Negative 4 times positive h, so negative 4h. Then we've got take away x squared, and take away negative 4x, so plus 4x this time. Okay? Right, and that's all over h. Let's simplify our numerator. So hopefully we can see we have got an x squared and a minus x squared, so that's good, they're going to cancel out. We've also got a minus 4x and a plus 4x, so they're going to cancel out. So what are we left with? What have we got? We've got 2hx plus h squared minus 4h all over h. Okay, So now we can't simplify the numerator anymore. We are going to divide every term by h. Okay, it's not just one of the terms, every term gets divided by h. So we get 2x plus h minus 4. Okay, and now finally, that's as simple as it goes. So we do our final step, we take the limit as h tends to 0. So this is like pretending that h is 0. Okay, so we are left with 2x, there's no h there, so it's just the same. The h goes to 0 and minus 4. Okay, and there we go, we've done it.